Welcome to the third week of first lecture on IPCC projection scenarios, and we are going to talk in detail with respect to SRES scenario. Friends, in first 2 weeks we discussed about the science, the basics of the science behind the climate and climate change. Now this week let us understand what are the different scenarios and what is the requirement of these scenarios. Friends, we have IS 92 before 2000 because it was given by IPCC in 1992 and then after we got SRES scenarios. Further we moved on to RCPs and now we are going ahead with SSP scenario. So the main logic, the main driver, inspiration between these scenarios is that we need to jumpstart with some kind of analysis, some kind of futuristic analysis or futuristic projections. So that helps us in evaluating or pre-assessing the future scenario in advance and be prepared along with some kind of adaptive and mitigation measures. So in today's lecture number 1 of week 3, let us discuss about the SRES scenarios, and to deal with that we will go towards the concepts. So what are the concepts we are going to discuss? We are going to discuss on these 5 concepts broadly: the SRES, the purpose and key characteristics of this SRES scenario, and what are the storylines, particularly the storyline and family and list of the drivers. And then we will move on to understanding the greenhouse gases emission trend with respect to the dominant greenhouse gases, that is the carbon dioxide, and then some of the future projections we will also see with respect to these SRES scenarios as far as land use, land cover change is concerned, the population growth trend is concerned, the temperature and precipitation scenario across the world, how it could be with respect to 2050, 2055 to 100 or end of this particular 21st century. And then towards end we will discuss about the use and future needs of the SRES scenarios. Friends, as we move on to understand the key purpose and the characteristics of SRES scenarios, which as you can know, as you can read it now, that SRES stands for Special Report on Emission Scenarios, and the first 3 bullets, the first 4 bullets in the blue ink talks about the IPCC assessment in terms of the climate science, and it advises to the UNFCCC. So what it means? The IPCC, that is the Intergovernmental Panel on Climate Change, it assesses the climate science and it advises to the United Nations Framework Convention on Climate Change, where that is one of the statutory activity or duty of IPCC to advise the UNFCCC, and it produces one of the scenarios is SRES, which has been used since 2000. This SRES scenario has have been developed, and we started analyzing it with respect to 2000 to update in comparison to the IS 92 scenarios, where we had 6 different scenarios abbreviated as A, B, C, D, E and F. So with respect to 1992, this SRES scenarios which was developed in 2000, it gives an update in terms of the prediction scenarios with respect to different aspect of the climate science. And these scenarios, particularly SRES here, is needed for long term analysis or long term scenarios analysis. We usually go up to 2050, 2070 or 2100 by end of this century. and this report explains the new emission scenarios and their development. So, what are the new emission scenarios? Accordingly, let us have a look around. The purpose purpose is this IPCC based SRES scenarios, they assess the drivers of the greenhouse gas emissions. They analyze the future uncertainty. So, when you take more than one kind of one type of scenarios, it includes several drivers and makes a conditions or gives a set of conditions. So, that means it includes lot of future certainties and also uncertainties. We are more worried about the uncertainties. So, when we say that it includes lot of uncertainties, that means we group or we come out with a range of the output in terms of CO2 emissions, in terms of population growth based on various kind of emission scenarios. And this kind of scenario based analysis, they support the climate and climate based impact studies or impact assessment studies, but specifically not of the prediction in nature, not of the prediction of real nature. Coming to the key characteristics, the wide range of drivers and emissions, no extremes, no probabilities, open multimodal design, and there are 4 storylines in terms of families. As you can see from the tree, the SRES scenario trees, you can see the upper one is the economic, that is A. So, within that we have A1, A2 based on the global and the regional categories, and the lower one is the B, and again based on the global and regional categories we have B1 and B2, and you can see the various driving forces as population, economy, technology, energy, land use and agriculture. These 6 are put under the various type of driving forces which actually drives the change and lead to understanding of the climate or climate related change, in turn the climate science. Now, friends, let us move towards understanding the branch, the tree which is shown in terms of various branches as far as the SRES scenario is concerned. As I just mentioned, we have A1, A2, B1, B2 in terms of broad storyline or family. You say the A is economical and B is the environmental, 1 stands for the global and 2 stands for the regional kind of things. And accordingly, you have 40 different scenarios. So, the subgroups also we have in terms of A1 family, we have fossil intensive, which is abbreviated as A1FI, fossil intensive stands for FI, A1T, which is a non-fossil based kind of scenario or grouping, A1B, which is again a balanced energy mix, and the other subgroups include a kind of harmonized and a kind of other scenarios. What do we mean by a kind of harmonized? Harmonized means the scenarios that share a consistent set of core assumptions or the data inputs, and whereas the non-harmonized or you say the other scenarios, they use varying assumptions allowing for exploration of greater uncertainties of different nature. So, that means it is the vice versa. So, harmonized gives a more consistent set of core assumptions with solid data inputs, whereas the other scenarios are rest that include more of uncertainties. So, this is how you make a combination of 40 different scenarios under the families or group or the storyline within the SRES. So, which has been given by IPCC in a report published in 2000. The 4 SRES storylines represent different world futures in 2 dimensions, as we just mentioned, a focus on the economic or environmental concerns, and second is global or regional. Accordingly, you have 1 or 2 category, and A and B based on the economic and environmental concerns respectively. So, you have A1. If we go in detail, A1 is a very rapid economic growth with increasing globalization an increase in general wealth with convergence between the regional and reduced differences in the regional per capita income. So, what happens? The materialist consumist, or you say materialist consumerist values predominant with rapid technological changes, whereas the low population growth. Three variants within this family make different assumptions about sources of energy for this rapid growth. What are those three? As you just mentioned, the fossil intensive A1FI, the non-fossil fuels A1T, or a balance across all sources such as A1B. Note that only the A1FI variant is considered in this analysis within the A1 framework, not in any other sets. Similarly, I have also mentioned A2, B1 and B2. So, let us have the B1. For example, same low population growth as A1, but development takes a much more environmentally sustainable pathway with global scale cooperation and regulation. Clean and efficient technologies are introduced. The emphasis is on the global solutions to achieving the economic, social and environmental sustainability. So, you can see in the B we are giving more of the environmental concern, or we are considering the environmental concern. Now, let us have a look at the quantification. So, in terms of the quantification, if we put them under the broad framework of A1, A2, B1, B2 and corresponding to population growth, the GDP growth, the energy use and the land use pattern, and resource availability. You can very well see A1 in terms of population growth is very low. You can say global is 7 billion, and A2 it is saying a very high when you consider the regional pattern into regional things into consideration. So, that is 15 billion, and B1, B2, B1 again low 7 billion, B2 is 10 billion, a kind of medium. And let us take the GDP. The GDP, the gross domestic product, when you see it very high in terms of world GDP, it is about this much 525 to 550 in terms of the trillion dollars, okay, trillion USD. But when you move to A2, it is projected that it could be at a medium of 243 trillion, because production will be or growth will be less. And in terms of B1 scenario, where environment things are also introduced, it is also a high range of 328 trillion USD, whereas the B2 is giving you a medium of 235 trillion USD. As far as the gross domestic product per capita is concerned, you also have a figure there. But let us move to the fourth one, that is the land use and energy use changes, very high in terms of the A1, whereas A2 it is high to medium. In case of B1 also it is low and high, whereas in case of B2, where the environmental and regional considerations are there, it is medium in terms of the energy use and land use. Similarly, for resource use, in terms of A1 it is very high, A2 it is low, B1 also low, whereas B2 it is medium when we consider the environmental and regional aspects as far as the SRES family of B2 is concerned. Now, based on this, let us have the carbon dioxide emission in different families. So, friends, we have in the fiction the A1, A2, B1 and B2, and in the and on the y axis you can see the global enriched carbon dioxide emission, which is represented in terms of gigatons of carbon per year, and they all move from 1990 to 2100. Whereas you can very well see that the colored emission bands shows the range of harmonized and non-harmonized scenarios, whereas the A1 family shows the widest spread due to rapid economic and or the technological shift. You can see it in terms of the upper left figure, where it is having a very wide range in terms of the rapid economic growth and the technological shift. When you move to the upper right, we can see the A2 scenario that keep rising due to high population and slower technological growth, whereas the lower portions B1, B2, B1 is a kind of trend reversal as far as the CO2 emission is concerned. It is turning in terms of the land use, whereas B2 is a moderate due to local sustainability. Now have a look at the global carbon dioxide concentration in terms of parts per million volume used in the SRES driven some HAT CM3 model in terms of the climate change projection. So 1990, 2020, 2050 and 2080 scenarios are there. So let us have a look at the A2. So A2 we may go up to, as far as the A2 prediction, the CO2 scenario may go up to 709 gigatons of carbon, 709 ppm in terms of the carbon dioxide in atmosphere. Currently we have about 425, so which is also seen in terms of 2020s for the B1 scenario and B2 scenario. So it is also very interesting to learn that these predictions came 25 years before. So during 2004 these prediction scenarios has been formulated, and if you see, we just crossed, we are into 2026 now, and as for 2020 predictions, the B1 and B2 scenario, which is 421 and 422, is perhaps matching closer. So this is also a take or a validation study as far as the SRES B1 and B2 scenario is concerned, whereas A2 looks to be also a closer. A2 scenario, A2 and A1 F1 looks to be slightly pessimistic, because we were around 2020 we are about less than 420 ppm of carbon dioxide in the atmosphere. Now similarly, they have the cumulative emissions between 1990 to 2001 has been plotted in terms of x axis in both the figures, and on the y axis the number of scenarios. So when we take the number of scenarios, what we found in terms of all these 4 cumulative carbon dioxide bins, all are low to high kind of range has been shown. So lowest bin have been shown by few scenarios, medium bins by most scenarios, highest bin by only A1 Fi, whereas the in terms of bar height, which represents the number of scenarios. The come to the right and upper right side diagram, the B1 scenario, where it is very strong long term carbon dioxide reduction, families spread widely, not grouped tightly, indicate large long term uncertainty. So this is what is really understood, what we get to say that yes, all these various kind of scenarios gives us a set of carbon emission perspective across different years. So that helps us in preparing ourselves in terms of managing, adapting and mitigating in terms of CO2 emission scenarios. Now let us move on to the gross domestic product in terms of the GDP per capita and the total GDP in terms of the world scenario. On the upper right, we can see A1, A2, B1 and B2, all 4 different different curves. So the pessimistic or the highest one is shown by A1, whereas the lowest one is perhaps by A2, which is the economic but regional aspect is considered. But in the medium is shown by B1 and B2 in both the cases. So what we mean that the A1 is a very pessimistic, whereas A2 is a very optimistic kind of scenario, whereas B1, B2 gives us an indication that they are a more moderate and realistic kind of scenario as far as the carbon dioxide emission is concerned in future years. Now let us move on to the population, and similarly on the upper right you can see this the scenario as for 1995, whereas the A2 world scenario for 2055 is shown in the lower left side of the slide, and you can see lot of population growth is projected. And if we focus over Indian subcontinent, it will be very clear that yes, there is the population growth is very high as far as the A2 projection is concerned. And in terms of the global LULC change under the SRES scenarios, cropland, grassland and forest, same way we have brought out the A1 FI, B1 and B2. So, cropland, grassland and forest. Look at the grassland and cropland. They look the pattern is similar, but the scenario wise pattern is different to understand, whereas in terms of the change from 1990 in terms of millions of hectare of area which is shown for the cropland from 1900 to 2100, 1990 to 2100. The A1 FI is a very what do you say optimistic here, I would say, because it is showing very less in terms of the change, and similar with the forest also you can see on the very upper right kind of thing. So, it is well explanatory in terms of global land use change under various SRES scenarios. And taking this in terms of carbon dioxide emission. So, land use land cover vis-a-vis carbon dioxide, putting them together on the y axis, it is the index 1991, and we have the variation shown in terms of minus to plus 3.5, and on the x axis it is varies between 1900 to 2100. Most scenarios peak mid century, during the mid century period. After mid century, emission declines, as the reason is there could be a decline in the emission scenarios beyond mid century, because there will be no forest to be deforested. That means the rate of deforestation will be at the minima, because it will slow down. A2 stays positive throughout 2100, whereas A1 also shows a very wide range of variation. This is what actually we get from different kind of scenarios analysis. We have all 40 groups or families of storyline, as we understand now. Now, friends, let us see in terms of the variations in the regional pattern of temperature and precipitation. And here the two diagrams are the images. The left hand side shows the temperature, and the right hand one is the precipitation. And the upper in case of both has a different color bar corresponding, which is mentioned on their respective right hand sides, and the lower three have a different color bar because the range is different. So, let us see the lower three corresponds to A2A, A2B and A2C, whereas the in terms of the left hand side it is temperature, and the right hand side it is precipitation. So, similarly, when we come out with this kind of analysis, we really know that where what is going to happen or could happen. So, that itself enriches us with information in terms of dealing with the probable risks in terms of adaptation and mitigation measures. Now, the use and future needs of the SRES scenarios. So, use of SRES, this helps us in terms of exploring how different socio-economic pathways affect the future greenhouse gas emissions, and also by using this SRES, it supports the climate modeling, impact studies and mitigation planning, because we know things in advance perhaps. So, this could happen if this kind of situation happens. So, this actually helps us in what you say imagining a set of conditions or a set or future scenario based on this analysis. So, it also helps in terms of comparing the scenarios with similar emissions, but different socio-economic conditions. So, various scenarios gives us various comparison. That's how we also learn that yes, where to do what in terms of adaptation and mitigation measures. avoid mixing components from different scenarios to maintain consistency, and that is how the use of SRES scenarios provide long term context for policy level decision making. Now, in terms of the future works on emission scenarios. So, it helps in terms of expanding and regulating expand and regularly update the global emission scenarios database, build modeling and scenario development capacity in developing countries. It also helps in terms of using multi-models, the multi-storyline approaches to capture the uncertainties, improve representation of land use and non-carbon dioxide gases and aerosol processes, incorporate the climate emission feedbacks and the sector specific details. So, in nutshell, what this scenarios helps that if we have we get several if and but kind of scenarios. So, we also get a comparative information in terms of the if and but kind of scenario that helps in dealing with that in terms of adaptation and mitigation measures. And these two references have been picked. Importantly, the reference one is the important reference comes from IPCC 2000 report on the SRES from working group 3, and a publication or peer reviewed publication appeared in Global Environmental Change by Arnold et al. In 2004 also has been utilized. Some of the figures and tables have been picked from there. So, friends, what we discussed, what we learned from this from the SRES are the scenarios. As I mentioned in the very beginning, we have 4 different sets of scenarios. The second one, the first one we talked about 92 IS, that was given by IPCC in the year 1992, that has 6 set of scenarios abbreviated as A, B, C, D, E, F. Here in this SRES scenarios, we have 4 broad groups. So, A1, A2, B1, B2, as we know, A for the economic aspect, B for the environmental aspect, 1 for the global and 2 for the regional aspect. So, accordingly 4 major groups, and then we have the fossil in and fossil out or with or without, accordingly A1 Fi and simple A1 T1. So, A1 T. So, these kind of scenarios we discuss in SRES. In our future classes, we will discuss about the RCP, representative concentration pathways, in terms of their their radiative forcing. So, we will discuss in the next class, that is the lecture number 2 in terms of week 3, and the next one are the currently in particularly for the AR, that means assessment report 6 and 7. 6 we have already started using another scenario called SSP, shared socio-economic pathways, and the 7th one also will take will see lot of analysis from the SSP scenarios or using the SSP scenario, socio-economic pathway scenarios. So, in nutshell, the SRES scenarios are this scenario, this set of 4 scenarios. I jump started with SRES, giving a very brief mention of the 1992 6 scenarios given by IS 92, but SRES we discuss what they are, what is their purpose, how they incorporate different drivers, and they see the impact of the project, the impact based on the global and regional prospect. So, with this we will move ahead in terms of RCPs in the week 3 lecture 2. Thank you very much for your listening.